All right. So we're going to be continuing to talk about confidence intervals for the mean. But this time we're going to be concentrating on when the sample sizes are small. In other words, when your sample size is less than 30. So we have to change things a little bit if it's less than 30. Now before we start with that, let's kind of review how to find the minimum sample size we need to estimate a mean. Well, here is the formula. So we need, I'm not going to write the steps, we need Z, which is your critical value. And that's found by using that inverse norm or by looking back at the sheet you did yesterday. Then you need S, which is your standard deviation. And we need E, which is our margin of error. So, a couple of examples of that, and then we'll get on to what to do when we don't have a lot of data. Okay, so this one says our confidence level is 0.90. So that's 90% confident. Standard deviation is 6.8 with an error of 1. So I look back at my chart for if I have a confidence level of 0.90, my z-score is 1.64. And I know everything else. So the z-score times 6.8 divided by the 1, by the error, squared. And you can do this as one fraction. You can do this as two steps. I'm going to do it 1.64 times 6.8 divided by 1 and then square the answer. I get 124.36, but how do I have 0.3 of a person or of a thing? I can't. So we need a sample size of 125. We're going to round up. If our confidence level is 0.98, that's a z-score of 2.33. And we'll just plug everything in the formula. That's going to be 2.33. This time my standard deviation is 10.1 divided by the error, all of that squared. And I got 138.45. So my N really needs to be 139 minimum. Would it hurt to go 140? No, not at all. Okay, so we've talked about normal distributions, standard distribution. There's also something called a T distribution.
Hello.
Hello. So there's 5 properties for a T distribution. Number 1, it's bell-shaped. And symmetric. So it's kind of like a normal curve. The area underneath.
Have a good day.
You too. is 1 or 100%, same as a normal distribution. The mean, median, and mode, equal 0. Oh, that's sounding the same too. But instead of using standard deviation, this one is determined by what are called degrees of freedom. Degrees of freedom. And creatively enough, degrees of freedom is abbreviated DF, degrees of freedom. And it is a lovely formula. You take your sample size and subtract 1. That's how we determine a t-distribution. Now, as the degrees of freedom increase, the t-distribution approaches a normal, perfectly normal distribution. But we use a t-distribution used when n is less than 30. So we have less than 30 samples. We can't do what we normally would do if we have less than 30. Oh, isn't that horrible? So, we have to be able to figure out how to find a critical value of t. In other words, we want to find, instead of z, it's not a z-score, it's a t-score. First thing we're going to have to do is calculate the degree of freedom. The degree of freedom is equal to n minus 1. The next thing we have to do is identify the level of confidence. Now, to find the critical value, and I hate to do this to you, but really the easiest way is to use a t-table. So we're going to learn how to use that today. Now, once we have our critical value, we can make our confidence interval. So we need to either calculate or identify the following things. We need to know how many things we have, our sample size. We need to know the mean. So this is sample size. This is the mean. And we need S, which is the standard deviation. We need the degrees of freedom. Then we need to calculate our margin of error. So use the degrees of freedom to find, sorry, I forgot to write that, find our critical value. Then we can find our margin of error. Error is the critical value times the standard deviation over the square root of n. Look familiar? The only difference is instead of using a z-score, we're using a t-score. Our confidence interval is from the mean minus the error to the mean plus the error. That's it, folks. Same exact we were doing yesterday, but instead of a z-score, you're finding a t-score, and I apologize. We're going to have to do that we're going to use a table for that today. So, let's see what all we can identify. Assume the variable is normally distributed and use a t-distribution to construct a 95% confidence interval. So I already got my C. C is 0.95. That's cool. The next thing I need to find is how many values I have. So in a random sample of 8 phones, the mean was $110, and the standard deviation is 14.25. Coolness. Next step is to find the degrees of freedom, which is n minus 1. So in our case, that's 8 minus 1. Our degrees of freedom is 7. I'm going to use that to find my critical value. So you should have been given, or if you're not, just stop and go get this, a t-distribution chart. Down this side it says DF, that's your degrees of freedom. The top it says confidence interval. So I'm looking for a confidence of 95% and a degree of freedom of 7. So 7 on the degree of freedom, and you'll have to, sometimes it helps to have either a ruler or you can pull it up your page. Degree of freedom is 7, confidence of 95%. That puts me at 2.365. So, my error is going to be 2.365 times the standard deviation divided by the square root of our number of values. So 2.365 times 14.25 divided by the square root of 8. I got 11.92. So for my confidence interval, I'm going to take my mean minus that. And then over here on the other side, it's going to be the mean plus that. When I subtract 11.29, I get 98.08. And on the big side, it's 121.92. This means I am 95% confident that the average, what was this, cost of repair, average repair cost is between 98.08 and 121.92. Gosh, it seems so similar. It's because it is. It's very, very similar. In a random sample of 11 HD 4K TVs, the mean, so this is my N is 11. The mean repair costs is 225, and the standard deviation is 57.50, and I've got 90% confidence. So second step, degree of freedom is n minus 1, so 10. We're going to find the t value by looking for the degree of freedom. I'm going to fold my paper up because it makes it easier. And then going across, and I'm looking for 90%. 90% degree of freedom of 10 is 1.812. Error. Your critical value, times standard deviation over the square root of the number of values. So I'm going back to that original n. And I get 31.41. And then you would take your mean and subtract it. And then on the other side, you would add it. So we would say, with 90% confidence, the mean repair cost is between $193.59 and $256.41. We'll go ahead and hand out the worksheet right now. The first page on the worksheet, it has a little bit different notation, but it's looking for the t-scores for certain percentages. So you'll be using this chart for the first part. Then it asks for confidence intervals, which you'll be doing exactly like we did last time.